This videocast will focus on solutions to the Practice on Dimensional Analysis worksheet. Make sure you have this worksheet and your work in front of you, and then also remember that you can pause, replay, and repeat any portion of this videocast as we go along and do these problems. Let's take a first look at the metric system here listed on the top of the Practice on Dimensional Analysis worksheet, and you can notice that the prefix is mega, kilo, hecto, deca, and then our base unit right here, deci, centi, milli, nothing, nothing, micro, nothing, nothing, nano are all listed with their symbol and how much larger or smaller something is than a base unit. And we can use this to effectively work many of the problems that are on this worksheet. So I'll just bring back this worksheet periodically, and we'll start with number 1, and we'll work through as many of these problems, we'll work through all of these problems step by step. And remember, you can fast forward if you don't need to see some, and if you'd like to see them again, of course, you can rewind and repeat. So number 1 says 4.2 liters, and we want to go to milliliters. So first step, remember, write the value that you have and the units that you have, put a multiply sign, put a line. After you've done that, simple first step, now take and put the units that you have in a position where it's going to cancel. So you want to put liters in a position where it's going to cancel, so put them down here. Put milliliters as your new set of units, and then take and find what's called the conversion factor, or the relationship between milliliters and liters. And if you look up here in the metric system prefix diagram, you can see milli is right here, and liter, of course, is a base unit right up here. And so the difference between milli and the base unit you can count as 10, 100, 1,000, or there are 10 to the third or 1,000 of the small unit in the big unit. Okay, there's 1,000 of the smaller milli units in the big unit. So then when you come back to do this, make sure that you put the 1,000 with the small unit and 1 with the big unit. So you end up multiplying 4.2 times 1,000, or if you want to put it in scientific notation, which the directions ask you to do, 4.2 times 10 to the third. Or sometimes if you see it on your calculator, you'll see it written like this, 4.2 e to the 3. Remember, the e simply means the times 1, 0, or times 10 to the third power is replaced by the letter e. Either way is acceptable to write on an AP exam and will be acceptable throughout this class. Number 2, it says 227 CG, and then it says 2 capital MG. 227 CG to capital MG. So the first thing you do is write what you have, put a multiply sign, put a line. Now put CG in a position where it's going to cancel. Put capital MG as your new set of units. So CG, remember, cancels with MG. Remember, always put your units in first, then look to see what number to put in. Find CG on the prefixes chart. Here's C right here, and G would just simply be a gram, meaning it's a centigram. And we're going to go to the capital M, or megagram, way up here. Now if you look, this is times 10 to the negative 2, which means it's 100 times smaller than a base unit. 100 times smaller than a base unit. And then if you look at mega, mega is 10 to the 6th, or 1,000,000 times larger than a base unit. So if you add those together, we're going to end up with 10 to the 8th, 10 to the 6th plus 10 to the negative 2. 10 to the 8th difference. So the question is, where do I put that 10 to the 8th? Is it 10 to the 8th of centis in a mega, or 10 to the 8th megas in a centi? Remember, these are always the smaller units down here, and there are always lots of small units in a big unit. So you're going to have 10 to the 8th of the small things in the big thing. So on my sheet now, I'm going to put 10 to the 8th next to the smaller unit, which is the centigram, and 1 next to the megagram. And then I could write this in scientific notation simply by writing it as 227 times 10 to the 8th. And of course, if I wanted to write this as math teachers would like me to take and only have one number in front of the decimal point, I'd move this 2 places over, which means this would raise to 2 numbers, and it would be 2.27 times 10 to the 10th. That's number 2. Number 3, it says 3.4 times 10 to the negative fourth, 3.4 times 10 to the negative fourth deciliters to nanoliters. So put 3.4 times 10 to the fourth dl, put dl in a position where it's going to cancel, put nanoliters as a new set of units, and now you need to find the relationship between deciliter and nanoliter. Cancel your units first so you know what's going to cross off, and make sure you put the deciliters in a position where it's going to cancel because that's the units you have. Put the new units as the ones that you want, and now relate deci to nano. So deci is right here. Here's deci, the small d, and nano is way down here towards the bottom. Now start from the small unit and count up, or look at the exponent for that. It's 10 to the negative ninth, and deci is 10 to the negative first, which means you are 8 steps apart. So you're 10 to the 8th apart. Let's count to make sure. Start here. This is 0, and then this would be 10, 100, 1,000, 10,000, 100,000, million, 10 million, 100 million. You're 100 million difference, or 10 to the 8th, right? Because 100 million is a 1 with 8 zeros after it. So 100 million, are there 100 million of the nanos and the decis, or 100 million of the decis and the nanos? Well, which one's smaller? Remember, you want to have a lot of the small units in the large unit, and the nano is smaller than the deci. So you're going to end up with 10 to the 8th of the nanos in one of the decis. And so if you remember back to math class, when you're multiplying two numbers together, this is technically 1 times 10 to the 8th. Multiply the front numbers, 3 times 1, so you end up with 3.4 times 10, and then take the exponents and simply add them. So negative 4 plus 8 gives you 4. So 3.4 times 10 to the 4th, and then you put NL there for nanoliters. That's number 3. Number 4 says 8.10 times 10 to the 10th. 8.10 times 10 to the 10th. Remember, these are the steps. Write out what you have, put the units on them, and it happens to be micrograms, and then put a multiply sign and put a line. Put a multiply sign and a line. And it wants you to go to kilograms. So where do you want to put kilograms? You want to put that as your new set of units, and you want to put micrograms in a position where it's going to cancel. So put micrograms on the bottom so it cancels with the micrograms. Put kilograms as your new set of units. Notice I put the units in first and cancel them before I put any numbers in. Before I put any numbers into this parenthesis area, which is called the conversion factor. Now you need to figure out how are micrograms related to kilograms. So let's look back at the metric system prefixes chart. Here's micro, okay? And we're going to go to kilo, which is up here. And I'll do it in different colors so you can see it a little bit better. Here's micro right here. Here's kilo right here. Now, you can look at the prefix, and then you can also look at the numerical value right here. It's 10 to the negative 6th, which means there's 1 million of the micro in a normal base unit gram. And then if you look at kilo, you can see that's 10 to the 3rd, or 1,000 times bigger than a base unit. So simply add the exponents and you'll know how far they are apart. And 6 plus 3 is 10 to the 9th, or 1 billion apart. And if you're not sure, go ahead and count from here. And each step on here is worth 10. So you have to be able to count by tens. 10, 100, 1,000, 10,000, 100,000. Million, 10 million, 100 million, billion. So you're 10 to the 9th, which is a billion, apart from each other. Now, do you put the 10 to the 9th? Do you put the 10 to the 9th as 10 to the 9th micros in a kilo, or 10 to the 9th kilos in a micro? Well, you want to put a lot of small units in a big unit. Remember, there's a lot of these things in a big one. So you'll have 10 to the 9th micros, 10 to the 9th micros in a kilo, 10 to the 9th micros in 1 kilogram. Now, to do this without a calculator, you have to remember rules of exponents, okay? 8.10 times 10 to the 10th times 1 is easy, but then divided by 1 times 10 to the 9th is not so easy. So I'm going to write it out like this, so then you can see this again in case you forgot from math class. This will turn out to be 8.10 times 10 to the 10th times 1, which is this number, divided by 1 times 10 to the 9th. Now these two numbers you simply work together with and divide by each other. And of course 8.1 divided by 1 is 8.10. Now these parts right here, since they're exponents, so when they're being divided, it means you subtract the exponents. So it's 10 minus 9, and 10 minus 9 is 1, so this would be times 10 to the first. 8.10 times 10 to the first, or it could also be written, moving the decimal point one place this way, as 81.0. The questions on the, or the instructions on the worksheet asks you to write everything in scientific notation. So circle, square, star your box, your answer here, and then make sure you have your units on the end, kilograms right here, because kilograms are the units that I have. That's number 4. Moving along, number 5. Number 5 says 2.5 times 10 to the negative third, 2.5 times 10 to the negative third meters to millimeters. So now put meters in a position where it's going to cancel. Put millimeters as your new set of units. Notice your meters are going to cancel with your meters. Always put your units in first before you, this is number 5 by the way, before you put any numbers in. Now relate meters to millimeters. Well, where's meters on this chart? Well, meters is a base unit right here. Meter is a base unit. Where's millimeter? Well, it's right down here. It's milli. 10 to the negative third, or 1,000 times smaller than a meter, which means there's 1,000 of the small unit in the big unit. 1,000 of the small unit in the big unit. Which one's the smaller unit? The milli. So I have to put 1,000 in here for the small unit, or 10 to the third in here for the milli, and then 1 for the meter. So 2.5 times 10 to the negative third times 1,000 times 1. Now if you want to punch it in your calculator, you can, but here's the easy way to do it. Write this as an exponent. This is the same as 10 to the third, or 1 times 10 to the third. Now multiply the two front numbers, 2.5 times 1, that's 2.5, and then add the exponents. What's 3 plus negative 3? Well, 0 times 10 to the 0th power. What's anything to the 0th power? Well, 10 to the 0 power is 1, so your answer is going to end up being 2.5, and the units on that are millimeters. There's number 5. Let's go on. Number 6. 6 says that there are 3.4 times 10 to the negative 4th grams per milliliter, and it wants us to go to kilograms per liter. Ooh, a double one now. Double one. So we're going to end up with two relationships. So go ahead and put a multiply sign on a line, and if you want to, go ahead and put a multiply sign in the second line, because you're going to have to convert two things. The thing they want us to go to is kilogram per liter. Kilogram per liter. So put your grams in a position where it's going to cancel, and put your kilograms as your new set of units. That takes care of one of them. If I stopped right now, I'd have kilogram per milliliter, but I don't want that. I want kilogram per liter. So now, second thing I want to do is I want to take and put my milliliters in a position where it's going to cancel, and put liters as my new set of units. Notice where milliliters are here. They're on the bottom. They're on the bottom of this fraction. So I want to put milliliters on the top up here to get them to cancel. Put liters as my new set of units. Notice how milliliters will cancel with milliliters. Okay? Now I've canceled my units and I've got kilograms per liter left. And notice I haven't put a single number in yet. I haven't put a single number in yet, because you should put your units in first and then put your numbers in. So let's relate gram to kilogram. You might know it in your head already, but let's just take a look at it right here. Gram is right here, it's a base unit. Kilogram is up here. Start from the small unit and count up. 10, 100, 1,000, 10 to the third of the small unit in the big unit. So 10 to the third of the small unit, 1 times 10 to the third of the small unit in the big unit. Now take a look at milliliter and liter, and how are milliliter and liter related? Well, here's liter, right here, it's a base unit. And then I want to go down to milliliter, which is right down here. Notice it's 10 to the negative third, which means there's 1,000 of the small unit, or 10 to the third of the small unit, in one of the big units. Where do I put the 10 to the third? Well, I put it with the smaller unit. My smaller unit is the milliliter. So 10 to the third, 1 times 10 to the third milliliters in 1 liter. Now notice, if you're savvy at math, the 10 to the third is on the top and on the bottom. Holy cow, they cancel. Now, as a matter of fact, I'm only multiplying it by 1 and dividing it by 1. So what's my answer to number 6? Well, 3.4 times 10 to the negative 4th, but my units now are kilogram per liter. Kind of cool, because notice how the volume unit changed by 1,000 and the mass unit changed by 1,000, which in fact canceled it out. You end up with the same exact number. Moving on, number 7. 7 says we have 9.4 times 10 to the 5th, 9.4 times 10 to the 5th joules per second, and then we're going to go to kilojoules per hour. So multiply sign, put a line, and then go ahead and multiply sign and put a line again, because we're going to move 2 things, or change 2 things to kilojoules and hours. And we're going to need our calculator for this one, because we're dealing with hours and seconds, which are not totally 10-based. So anyway, choose which one you want to deal with first, and let's deal with joules to kilojoules. So put joules in a position where it's going to cancel, put kilojoules as your new set of units, and there's going to be an amount of joules in a kilojoule, and we'll figure out that in just a second. And then secondly, take your seconds and put them in a position where they're going to cancel in here, and then put hours as your new set of units. So notice where seconds are right here. They're on the bottom of this fraction. So you're going to have to put seconds on the top of this new fraction, put hours on the bottom, because you want seconds to cancel with seconds. And you can go ahead and cancel those right now in the joules right here now too, so then you know that you're ending up with kilojoules per hour. Always a good check to make sure that you're ending up with your hours by canceling your units right away. Now go back and take a look and figure out how many kilojoules there are in a joule, or how many joules there are in a kilojoule. So where's a joule? Well, a joule is right here. It's a base unit. Okay, where's kilo? Way up here. Times 10 to the 3rd. Okay, so that means there's 10 to the 3rd of the small unit in the big unit. 10 to the 3rd of the small unit in the big unit, or 1,000. So there's 10 to the 3rd, 1 times 10 to the 3rd of the joules in 1 kilojoule. Okay, second relationship is seconds and hours. Now you might not know this, but there's 60 seconds in a minute and 60 minutes in an hour, and 60 times 60 is 3,600. So there's 3,600 seconds in 1 hour. So now I'm going to show you how to punch these numbers into a calculator, because some people get really distraught when they have to put these kind of exponent numbers into a calculator. And so I'm going to bring the calculator on here live, and hopefully you can see this. And the first thing I'm going to put in is 9.4, so 9.4. I'm going to bring it a little closer here so you can see it really well. 9.4 times 10 to the 5th. Now there's 2 ways to enter the times 10 to the 5th. I'm a big fan of pushing the second button right here, and then pushing the button above the 7 where it says EE right here. It's on the comma, or the I think it's a comma, and it puts a little E on the screen that looks like this. See the 9.4 E? And then I put in the exponent, and the exponent is 5. That E right here takes care of the times sign, the 1 and the 0 of the times 10 to the. Now you can put it in as times 10 to the, and then put in caret and a 5 as well. You can do that, but be really careful of your order of operations when you're entering it. Okay, next it says multiply by, and then 1, and then divided by 1 times 10 to the 3rd. I'm going to assume that you know that when you multiply something by 1, it stays the same. So I'm just going to divide by 1 times 10 to the 3rd. So I'll hit divided by, and then I'll put in 1, the enter exponent button again, and then I'm going to put in a 3, because that's the same as 1 times 10 to the 3rd, which is right here. See how it looks on your calculator? Okay. The next thing it says is times 3,600 divided by 1. So on my calculator now I'm going to take and multiply by 3,600. See how easy that is to put in? You don't have to put in the times 10 to the stuff, or the times 10 to the stuff right here. The E's take care of that. Now hit enter, and it looks like my answer, if written in scientific notation, would be 3.384 times 10, and then take the decimal point from here and see how many places you move it over. 1, 2, 3, 4, 5, 6 places, which means it would be times 10 to the 6th power. So 3.384 times 10 to the 6th, and the units on that, of course, would be kilojoules per hour, which is what was left over right here. Now, another way to write this, since your calculator uses an E, is 3.384 E6 kilojoules per hour. Either way is acceptable using the E or the times 10 times 10 to the. Okay, now number 8. It says 3.33 milliliters, 3.33 milliliters per minute, and then it says we're going to go to liters per second, okay? So first thing you do is put a multiply sign and put a line, and then you're going to have to convert 2 units, so put a multiply sign and 2 lines, and then look. What are we going to do? We're going to take milliliters and put it in a position where it's going to cancel and put liters as my new set of units. So milliliters down here and put liters as my new set of units right here. And then we're going to go from minutes to seconds. And notice where minutes are on this. It's in the lower portion of the, or denominator, I guess you could say, of the fraction. So put minutes up here in a position where it's going to cancel and put seconds as your new set of units. So put those right here. Okay, now you need a relationship between milliliters and liters. So if you're not sure what it is, take a look on here. Where's milli? Here's milli right here. And where's liter? Well, liter is a base unit right here. So 10, 100, 1,000. There's going to be 1,000 of the small unit and the big unit. If you forgot that, you can always look at the exponent right here too. There's 10 to the 3rd of the small unit and the big unit. So 1 times 10 to the 3rd of the millis in 1 liter. And then lastly, you have to relate seconds to minutes. And hopefully you know that there are 60 seconds in 1 minute, and you can put that in. Now let's put this one into our calculator as well, because sometimes this is a little bit more difficult for people once again, just like we did in the last one. So we first of all type in 3.33, and then if you look here, it's times 1, so I'm not going to put that in. I'm assuming you know times 1 is just the same number. And then divided by 1 times 10 to the 3rd. I'll show you how you can put that into your calculator. So divided by 1, and then enter exponent. Notice how it puts an E in there. It's the second button right here, and then you hit the E key right here, which is above the comma. That makes a small E on your screen, and then you put in a 3 because that's the exponent. So I entered the exponent of 3. I did not have to put in the times, the 1, or the 0 because the E key took care of that. And then I'll multiply by 1 again and divide by 60. I'm not going to do the multiplying by 1, but I am going to divide by 60, and then I can hit enter, and I get 5.55 times 10 to the negative 3rd. 5.55 exponent negative, I'm sorry, did I say 3rd? I meant 5th. 5.55 times 10 to the 5th. Notice my milliliters cancel with my milliliters, my minutes with my minutes, and I'm left with liters per second. Notice how when I canceled my units, the only things uncanceled were liters over seconds, and those are the units that I end up with. Okay, number 9. Number 9 says 2.5 times 10 to the 12th. 2.5 times 10 to the 12th nanometers per gram, and then it wants us to go to centimeters per milligram. Nanometers per gram, and it wants to go to centimeters per, I'm sorry, megagram. I don't know if I said that right. So first step, put a multiply sign, put a line, and then since we're going to have to do it twice, go ahead and put a multiply sign and 2 lines. Put nanometers in a position where it's going to cancel, and then put centimeters as your new set of units. Notice I didn't put any numbers in now. This is number 9, by the way. I forgot to put a 9 up there. And then secondly, we're going to go from grams to megagrams. So put grams in a position where it's going to cancel. Notice it's got to go on the top because it's on the bottom down here. Put megagram as your new set of units. Okay, now I need a relationship between centimeters and nanometers. So if I want to look on my schedule right here, here's centi, okay, and then here's nano right down here. Okay, and if you want to count from the small unit to the big unit, each step here is worth 10. 10, 100,000, 10,000, 100,000, million, 10 million. 10 million. Well, a million is 10 to the 6th, so this must be 10 to the 7th. And if you look at the exponents right here, this is a 9, and this is a 2, a negative 9 and a negative 2, and the difference there is 7. So 10 to the 7 difference between these two. So there's 10 to the 7 of the small unit in the big unit. Well, which one's the small unit? Nano, obviously. So there's 10 to the 7, or 1 times 10 to the 7 of the small unit in 1 of the big unit. And you can write the 1 times the, or you can just write 10 to the 7th. They mean the same thing, because of course 1 times any number is that number. Nextly, let's take a look at gram to megagram. Gram to megagram, and if you're not sure what that is, we can take a look on here. Where's gram? Well, gram's a base unit, so it's right here at the base unit. And mega is way up here at the top. And you can count, and each level, of course, means 10. 10, 100,000, 10,000, 100,000, million. Oh, there's a million of the small unit, right down here, gram, in one of the big unit. And it would tell you that right here, too. This is 10 to the 6th. So there's a million of the small unit in the big unit. And which one's the small unit? In this case, it's the gram. So 10 to the 6th in one of these. Now, I'm going to show you how you can do this without your calculator and be quite successful as well, instead of putting it all in. Okay, first of all, we've got 2.5 times 10 to the 12th times 1, so we don't have to do anything, then divided by 1 times 10 to the 7th. Now, 2.5 divided by 1 is easy, that's 2.5. But when you have an exponent divided by an exponent, what do? Well, you subtract the exponents. Top minus the bottom. So 12 minus 7. 12 minus 7 is 5. So if I stopped right here, I'd have 2.5 times 10 to the 5th, because it would be 12 minus 7 equaling 5. Then I take this and I multiply it by 10 to the 6th. So I take this thing and I'm multiplying it by the 10 to the 6th right here, or I can write it as 1 times 10 to the 6th if I'd like to, because then that reminds me to take my 2.5 times 1, which is still simply 2.5. And then I take the exponents, and when I'm multiplying two numbers together, what do I do with the exponents? Well, of course, I add them. So 2.5 times 10 to the 5 plus 6, or 11th. And then check my units to make sure they cancel. Nanometer with nanometer. Gram with gram. What am I left with? Centimeter over megagram. Centimeter per megagram. That's number 9. Let's go on. Let's do number 10, the last one on the page. Number 10 says we start with 7.75 times 10 to the negative 4th, and that's megagram per microliter. Megagram per microliter, and we're going to go to microgram per megaliter. Microgram per megaliter. Ooh, this is kind of a fun one. So first thing you do is put a multiply sign, put a line, and since it's multiple units, you're going to have to put 2 multiply signs and 2 lines. And the first thing we're going to do is we're going to take our top unit and convert it to micro. So we're going to go from mega to micro. So put megagram in a position where it's going to cancel. Put microgram as your new set of units. Okay. And then secondly, we'll go from microliter to megaliter. So put microliter in a position where it's going to cancel. If I'm going to do that, I'm going to have to put the microliter on the top, so it cancels here. Put megaliter on the bottom, so put the capital ML on the bottom. Notice the capital M, not a lowercase m. Don't get that confused. This I didn't do a very good job of writing either. This is a micro. Notice now that my megagram will end up canceling with my megagram. My microliter will end up canceling with my microliter, and I'll end up with megagram per megaliter, which is exactly what it asks me to get. Notice I put the units in first, and then I put the numbers in. Units in first, then I put the numbers in, and always show your work with your units like that. Okay, microgram to megagram. Okay, micro, where is that? That's way down here, micro. Micro. And we're going to go to mega, which is way up here. Okay, let's compare it to the base unit. From micro to base is 10 to the 6th. And then from base to mega is also 10 to the 6th. Add the two exponents. 6 plus 6 is 12, so there must be a 1 times 10 to the 12th difference between the two. So there's 1 times 10 to the 12th of the small unit and the big unit. And which is the small unit, micro or mega? Hopefully you said micro. So there's 1 times 10 to the 12th micrograms in 1 megagram. That's my first relationship. Second relationship, microliter to megaliter. Ooh, this is kind of the same. Here's micro once again, and here's mega. once again, remember it was 10 to the 6th difference between here and the base unit, and then notice it was 10 to the 6th difference between base unit and a mega. Add those two together, that's 10 to the 12th. 6 plus 6 is 12. So there's 10 to the 12th of the small unit in the big unit. Which one's the small unit, micro or mega? Hopefully you said micro. So 1 times 10 to the 12th microliters in 1 megaliter. Oh, cool, I got some neat numbers here. Notice 7.75 is just going to be multiplied by 1 or divided by 1 the whole time. So in my answer I'll end up with 7.75, and then I'll put an E here because that's easier than writing times 10 to the, and then I add the exponents. Negative 4 plus 12 plus 12. So 12 plus 12 of course is 24, plus negative 4 is 20, so it'll be 7.75 times 10 to the 20th. And then my units of course will be micrograms per megaliter. Impressive. Good luck on your dimensional analysis practice.